hard to kind of get your mind around this part right here.
Okay.
It's like it's another step that I didn't know I was willing to take.
See? Huh?
Okay. All right, thank you.
See, this is where the formulas come in handy. This is where you have to understand that concept, or you really
that checklist at the very end that we talked about.
Yeah.
Okay, what was the third thing on that checklist? There was 3, right?
Normal, the mean. Yeah. So first you have to know it's normal. You have to know either the x is normal or the sample size is at least 30, right?
Oh, okay.
Then you automatically get that it's normal. The mean is that and that.
And
All
the rest
everything
of
else
it I
falls.
can control pretty much.
Yeah, and then it's just like all the normal distribution problems you've been doing, except you just now have a new standard deviation. That's it.
I see.
4 pit.
Well done.
All right, cool.
Thank you very much.
No problem. Okay, let's see.
You haven't graded the homework yet, right?
No, I'm going to do it tonight, though. I will do it tonight. Because I don't have everyone's until this afternoon.
The students are anxious about the project. So, because there's only 4 weeks left of the semester. So can you give them some general guidelines about the project?
Well, the first thing I'd say is you should talk to me if you have an idea, and then we're going to have to talk. We're going to have to do some work outside of class. I'll have to do a Skype conference or something so we can discuss this because we have 4 classes. We can't take up class time doing it.
Okay. So like Caitlin, she likes golfing.
Hmm?
So would it be appropriate for her maybe to do some kind of statistics related to golfing?
So here's the thing: you can do whatever you want. It doesn't have to be business related. If you like sports, you can do sports. Do something that interests you. That's what I would say.
Okay, but I guess our question is, what are we doing with it?
Yeah, guidelines.
Find something that interests you. Okay, I mean, so here's some ideas. You could, I'll just throw out some ideas. And by the way, if you don't have an idea for a project, I can give you some ideas. Okay, I know.
Well, like Shelley's working in another class in your social work class, right?
Substance abuse class.
On a substance abuse class, she's working on doing research and things of that nature for that. So she could probably use some of the data for that to have a project that dovetails with her other project. Is that?
Like, I want to know
Sure.
what's the amount of babies that are born in Delaware County addicted to drugs? Is that possible?
So you're trying to estimate something. Yeah.
No, I was going to ask them.
What's that?
I was going to ask them.
Right, but you're doing a survey. So you're taking like a sample, right? So you want to know. So you want to know, for example, from your sample what the estimate is, and then you want an error bar. So
No, I don't want that error bar either.
Yeah.
Because I haven't gotten to the...
So here's the thing. The best thing to probably do is kind of talk to me, because sometimes it's kind of like brainstorming. Like if you say I'm interested in golf, then I can say, well, what sort of things might you be interested in? And you can kind of talk to me. We can kind of flesh out some ideas. You have to have some idea of something you're interested in, like some sort of problem. Usually I think of it as a problem or a question that you have. I always wondered about this.
Should pregnant women be drip tested? It's got to tie into this other project, or it's not going to happen. So I'm just telling you.
Yeah, and you can take the final too. I mean, you don't have to do a project. You're absolutely not required to do the project.
Open book, open note final, because
Yeah.
if I don't have guidelines, there's no way I can do a project either. I'm one of those people. I have to have like a set of guidelines, or I can't do it. Like, been there, done that, and I failed the project because I had no guidelines, and I'd rather not fail it.
Yeah.
Like my other project is a PowerPoint. So,
Like, do you want
of
us
course,
to
it's going to
do?
tell us how many PowerPoints we have to have.
Like, do you want us to do mean, median, mode, standard deviation? Like what?
It depends on the project, really. Different projects are going to do different things.
That you're interested in, okay. So you think that you're interested in a certain area, and then you kind of think of, okay, what are some things that like for instance, there's a lot of statistics out there about Ivy Tech students, okay, and about working moms and and the success rates for the number of classes that you take. And so think of like what things, number of people that pass statistics class and what affects their passing rates and what, so think of something that you're interested in that you would like to do some research on where statistics can be used to help solve the problem.
Right, and so like if you say like, should pregnant mothers be drug tested, then you have to have some idea as to like, you have to have a little bit more to it than that.
Right, you need to take a look at comparison of women that are drug tested and the success of raising children or something like that. Are those that are drug tested, are they much more likely to have children that don't have birth defects or do have birth? I mean, there needs to be a number of things
So you could look at other papers, but there has to be some understanding of statistics, and you have to say they did this, and so.
So if we decide to do the final, can you send out like, not like the actual test, but
a
like,
study guide.
yeah.
Like a
Yeah, and it would just be like the homeworks, really. It'd be just like the homework. It wouldn't deviate from the homework problems, really. Okay, it'd be mostly word problems, but homework.
Well, then
problems.
I'll take the
Yeah,
final.
Brian. and by the way, let me just interject one thing before I ask Brian. I can give you problems too. Like, for example, one thing that you could do if you're interested, for example, like in public health, and Caitlin was talking about, and I was telling you guys before, the movies Civil Action. Okay, and part of the case of the civil action hinged on using the Poisson distribution. They proved that, or they showed that, the of this many kids being sick from leukemia was too unlikely. That's what got the case in the court. So there's all sorts of statistical things that have come up in the news and in pop culture or whatever that are interesting. So if you really can't find a project and you don't want to do the final
election, this is going to be an election of it's going to be historic. It's a historic election.
And there are some things like with elections in the past, like with the Bush-Gore thing. Okay, you could go back and look at the Bush-Gore. Why did they predict that Gore won when Bush ended up winning? Why did they? And they didn't realize it was going to be close at the time. They really thought Gore had won it by a lot. So how could they be that far off? Well, they didn't take a good sample. It's one of those things where we were just talking about. Sometimes, even though it's very unlikely, that error bar lies outside the real value. But the best thing to do is talk to me, because it's going to be one-on-one. Everyone's going to be different than you have the devil's in the details. Okay. Some things are going to be hard to do, like pregnant women and drug testing. It depends. It just depends. Offhand, I couldn't tell you. I would have to talk about it more. So if you have things, just go ahead and contact me on a class, and if you want to get started. And it's probably not a bad idea. I was going to wait till after we turn in the midterm, but if you want to start before, it can't hurt.
Take the terms.
The midterm at 12 weeks. Midterm at 12 weeks.
Better late than never.
There you go.
No.
Okay, we got to get some. Okay, we got to get some. Yeah, Brian, you have a question. Sorry.
I guess I just wanted to say that I hadn't finalized my project yet, but with mine, all I did was I kind of made, like you said, like I made a question or a problem for myself. I was like, see, in the game that I play with my friends, I want to decide and find out, using statistics, what character works best on a certain stage. And so I was just going to take random different, just samples and things, and information that I could from every match that we play on that specific stage, see who does the best, who has the most health or whatever.
Right. So one of the ways, and this kind of goes to some of the things about like if you do study something that's like open question like women and drug testing, you can take what's in the literature and you can do computer simulations. And that's how we do a lot of stuff. We do computer simulations. So you can do simulations like the type we're doing, taking samples. You say, if I took 100 samples, what do I see? Some problems we can't solve analytically. We don't have formulas for it. So there's things you can take samples, okay? But there are lots of things. If you're interested in learning more about finance, there's a lot of stuff with the stock market that has to do with the binomial distribution. There's a thing called options pricing that people won the Nobel Prize for this sort of stuff. So if you want to learn about different things also, you can do that. Yeah.
So for the final,
my checkbook and pay my
Is
bill.
it-
I want to steal it.
is it over the last half of the semester or everything? Because I don't remember anything for the first part of the semester, to be honest.
Well,
Didn't remember anything. Are you kidding me?
I mean, like, I remember how to do, like, the mean, like, all that kind of stuff that I've been doing, but some of it...
It'll be in the second half. Yeah, the final, yeah.
I'll just take the final.
And you have that option, yeah.
Okay, so here,
Both?
folks, if you guys are gonna do the project, I want you by Tuesday night to make contact with Matthew. So you've at least made an initial contact discussing options with him,
Yeah, I strongly suggest that.
okay? No later than that.
Yeah, because it's going to take a little while to kind of puzzle through it.
It's gonna take a while to pull things together.
Finding a good project's hard. It's not easy. It just doesn't jump right out. And you have to kind of think about it and refine it, and
I don't have time to do a project or other classes.
Yeah.
They're killing me.
that's
I was
okay.
up till like 1 o'clock last night.
That's okay. You don't have to. That's all right. Okay, so I have to get through this stuff though for today. Okay. Okay, so let's go ahead and do some examples. Let's just assume that we have some random variable. Standard deviation is 5. We take a sample size of 100, and we find that x bar is 21. So we're going to start off. We're going to say sigma is 5. Our sample size is 100. X bar is equal to 21. Okay.
I have a question. Are
Yeah.
you videoing this?
I am.
I missed the other stuff. The one you said just put the numbers in.
I started after the break, so I started videoing it. I'm sorry, I started after the break.
I do not have any of the formulas, so I couldn't finish it.
We're going to do them right now, so you're in luck. So now I want the 90% confidence interval from you. Okay, so let's think about this, right? So I want the 90% confidence interval. So I'm going to center my thing at 0. Okay. What is the percentile that I want here? I want the middle 90, right? So what is this going to be? It's going to be the fifth percentile, right? So now we have everything we need. Let's do this in Excel. Confidence interval is x bar plus or minus the margin of error. I know x bar. All I need is the margin of error, right? So the only thing I need here is I need the margin of error. And that's just going to be, and you can take your pick. If you want it to be positive, you can use the 95th percentile, okay? So I'm going to use the 95th percentile for a normal distribution that has a mean of 0. And what should my standard deviation be? Should it be 5? It's for x bar.
No, isn't it
5 divided
the
by...
square root of
Exactly, right. This is going to be 5 divided by the square root of 100, or 0.5. And this is everything I need to get the margin of error. Okay? I'm getting the 95th percentile for normal distribution with a mean of 0 and the standard deviation for x bar. So let's set this up in Excel, okay? Open up a new one here. Okay, so I'm just going to start. I'm going to say this is x bar, it's 21. My confidence is equal to 0.9. So I'm going to go ahead and I'm just going to put the percentile is going to be 95th, right? So the percentile is going to be equal to, and I'm going to do this in terms of a formula. I'm going to add half the tail to 90%, right? The tail, the two things combined in the tail is 1 minus 0.9, right? So I'm going to say 1 minus the confidence, divided by 2. That's what's in this tail right here, right? And then I'm going to add it to the confidence. And that's going to give me the 95th percentile, plus that guy there. Okay? So I'm taking this 90% and I'm adding what's in that left tail.
Your confidence is 0.9, correct?
Confidence is 0.9, Standard deviation, well, I should put the sample size here, right? Let me put it down here. So n's 100. S dev of x is 5. Get rid of that. So now S dev of X bar is going to be equal to 5 divided by square root of 100. Okay? So that's my X bar, that's my confidence, that's the percentile that I'm going to want to get. Okay? Yeah.
A little bit off subject, but do you know how to make a common formula in Excel?
For
Like if we're going to do that a lot, this divided by the square root of this, is there a way to make that like a common function?
not that I'm aware of, but here we're kind of doing it because if I change that, everything else is going to change.
Okay.
All right, so I've kind of set this up this way. Okay, so this is my standard deviation, and now I'm going to get the margin of error. Okay. Is everyone here right now, though? Everyone's at this point?
Why did you do on the percentile?
Because I want this value right here, right? This is going to be the actual margin of error. Okay? So this is the 95th percentile, right? I have 90 in the center. I have 5 in the tails. So this is the confidence plus 1 minus the confidence divided by 2.
So why can't you just say 95?
You could, but if I change the 0.9, everything else will automatically change. Otherwise, if I don't, I'm going to have to change it manually.
Can I see your formula for
Sure.
B4?
See? So if I want to change that confidence, all I have to do is change this, and it'll automatically change everything else at the same time. Okay. But you can type in 0.95 if you want. Okay. So I'm going to have the confidence plus 1 minus the confidence divided by 2. This is what's in the left tail, and this is what's in the middle, right? Okay. Okay, now we're ready. So the margin of error is going to be norm.ins, right? I'm going from a percentile, the 95th percentile. So I'm going to say this is my percentile. My mean is 0. That's always going to be the same. And my standard deviation is the standard deviation of X bar. Okay? And you can see Excel is literally coloring everything. You know, this is B4, my percentile, my 0 is just 0, and that's B8. Everybody's there? Did this appear?
I'm just gonna watch it, because I
Okay.
can't keep up with you.
Okay.
So.
Fair enough. But really, I mean, what is the hard part with the formulas, do you think? What is the thing that causes people trouble here? Because this is what the homework's going to be like. What's the hard part, do you think?
The only part that I missed was the formula in B4, the very, very end. If you could click that real quick.
Yeah.
I got it down, I got it right, but that the plus B3, is that plus the entire thing of...
Let me rewrite it this way. Let me redo it this way. I'm going to do it like this. Maybe it'll be a little clearer. So what I'm doing is I'm adding the confidence, which is the 90%, plus the stuff in the left tail. That's going to be 5%, right?
Yes.
Okay, so that's what's giving me my 95th percentile, my 0.95.
Okay.
Okay?
So the 1 minus B3 over 2, that's one quantity.
That's this tail, right? That's going to be the 5%, and then the confidence in the middle. But you can just type 0.95. You don't have to even compute it if you don't want to. I'm just showing you in general how to do it, okay?
Okay.
All right. So n is 100, nothing to type there. This is just 5, just type this in. Just divide by 10. Okay? Square root. All right? And that's my margin of error, and I'm going to round that off here.
Yeah,
A little bit.
I was about to ask that. Do you want that in?
Yeah, it's too big. Okay. So am I all done? I'm done. Nope. I need the confidence interval, right?
Yeah.
I have the width. I know X bar. So now I just add and subtract, right? So the lower endpoint, what's the lower endpoint going to be? Let's see, Morgan. How am I going to get the lower endpoint? What am I going to do?
Don't you just do X bar minus the margin of error?
You bet. That's it. Oops, I have to click the right cell. Exactly. That's the lower endpoint, X bar minus the margin of error. And the upper one then, that's easy, right? Just that. That's it. And now that's the confidence interval. So I'm claiming that I believe the true mean is within 20.18 to 21.82. Okay. I don't know, because I never told you what mu was. Okay. So, but that's what I think it's in. Yeah.
Can you click on
Mhm.
figure 11 real quick?
This one?
You took, oh, okay.
Yep. X bar is off the screen. Hold on. Hard to fit everything in. Yeah. X bar plus the margin of error. That's the upper endpoint. Okay.
Upper is plus, lower is minus.
Yep.
Okay.
If you use the 5th percentile, you're going to get negative. So then you're going to add it to X bar to get the lower and subtract it to get the upper. But, why make life difficult, right? Okay, questions on that? Everyone's good on that?
Can we actually look at what a problem's going to look like? Because I know it's not going to be given to us like that.
Well, I'm not going to give you homework on this for tonight because you're going to have the take home. But
So we're gonna have the midterm tonight.
right, I'm going to give you the midterm tonight. Yeah. So let's go ahead. I'll tell you, let's do a problem with our female heights. Okay. Notice one thing nice about the confidence interval is that the word problems don't really involve any interpretation outside of the fact that the true mean that we think the true mean is in there. So there's no claims or changes or anything like that. Okay. We're just computing an error bar on our estimate.
I know.
Okay.
So are we not having homework over this then?
We are, but it's not going to be. It's going to be with a hypothesis test the week after the midterm.
So we're going to have 2 sets of homework at one time?
Not really. We're going to do 2 weeks of the hypothesis test. So I'll give you some confidence interval, some hypothesis, and then the second week you'll have more hypothesis because hypothesis testing is long. So it'll kind of ease you in. All right. Don't worry. You'll be fine. Don't worry. Be happy. Okay. So I'll tell you what, let's go ahead and let's redo the example with our female heights again. Let's do another example. So let's go back to the female heights, and let's suppose that we know the standard deviation is 2.37. So this is how I will give it to you. I'll say suppose the standard deviation is 2.37. Okay. We want to take a sample size of 16, so we're going to know what the sample size is, and I want a 95% confidence interval for mu. So I know that's going to be X bar minus the margin of error, X bar plus the margin of error. So I'm going to have to take that sample and calculate X bar first. So let's get a sample of size 16. So we'll go back to our data. This is the data from the females. And I'm going to take my random sample of size 16. So go to data analysis, sampling. And notice that Excel has already filled everything in for you. Okay, all you have to do is change the 100 to 16. So it actually remembers a lot of stuff. It's very nice. So I'm just going to change that to 16. Okay, it's already selected the input range and the output range for me because I did it last time. Okay, so there's my random sample. So now I need some things, right? I need X bar. I need N. I need sigma of X and sigma X bar. Let's do that first. Okay, so I'm going to compute the average, the sample average. So I'm going to click at the first one and just hit Control-Shift down arrow. Okay. N we know is 16. Okay. We're told the sample standard deviation is 2.37. Okay, these are all given, right, in the problem. This is given. And now we need sigma x bar, right? So I need to take this guy here and divide it by square root of n. Okay?
Square root of n.
Mm-hmm.
Okay.
So now we have a lot of the pieces of the puzzle here. So I got this. Notice the thing that I'm getting when I do the norm.inv. I'm getting the number of standard deviations, right? That's what I'm actually getting when I do that percentile. I'm getting the number of standard deviations. That's what the margin of error is going to be. Okay, so let's go ahead and compute this. So our confidence, what did we say the confidence interval we wanted? We said 95% confidence interval. 0.95, you bet. Whoops. And so the percentile, I know that's going to be 0.975, right? I could compute it if I wanted to. Let's go ahead and do it. What the heck? Just to make sure we don't make a dumb math error. Whoops. Okay, I'm going to take what's in the tail and just divide it by 2. But I'll get 0.975. Okay. And now I'm ready.
I'm sorry, let me see that one more time.
Huh? I'm taking the confidence and I'm adding it to 1 minus the confidence divided by 2, right? So this is what's in the middle, and this is half of the tails. Okay? And that's the percentile. So these are the 3 things that I need. Okay? You need x bar, you need sigma, and you need the percentile. Okay, now we're ready for the margin of error. So what should I type for the margin of error here? What? Okay, I like that. Norm.inv. Okay. What do I do next, Brian? What comes next?
The probability is 0.95.
0.95? Everyone agree?
0.975.
0.975. Excellent. Okay. And then next?
0.
0. Good. And what's the standard deviation going to be?
That's the 0.5.
That's right. It's of x bar. Bingo. And that's our margin of error. Okay. Now everyone should have that number. Okay. This is constant no matter what your x bar is. That length is always the same. Okay. And again, it's always good to format things. You just don't want it. Just looks ugly. It's hard to read. So we'll just do 2. Okay. Now I want the upper and lower, right? So I know the lower is just x bar minus that. And of course, this is going to differ. No one's going to have that number, I guarantee you. But whatever your x bar is, okay, subtract it from that.
That's so weird. My
What's-
x bar is exactly 64.
Yeah, and some is being rounded off too, but you never know. Okay, and then the upper end point is going to be x bar plus margin of error. And that's all you have to do. So there's no problem that I'll ask you where you're not doing exactly this. Okay?
X bar minus the margin of error and X bar plus the minus of error.
That's it. That's right. Yep. Just like 45% plus or minus 3%. The true one's between 42 and 48. Okay, those are our endpoints. And that's it. Except for one thing. So there's something that we have a problem with. But any questions about this calculation? This is the basic calculation right now. We want to get this down. Okay. Now here's the hard part. We have a huge problem in that we're assuming we know sigma. So Caitlin said, how do you know sigma? And I said, well, I know it from the population. But there's a problem with this. You think about it for a second. You generally need to know the mean to compute the standard deviation. Okay? So if I don't know what the true mean is, how do I know what the standard deviation is? And the answer is, I usually don't. Okay? Sometimes people give hand-wavy arguments. They say, well, we know in cases like this, or in the past it's been this, okay? But it's still an assumption. If the mean can change, the standard deviation can change. So generally, we have to drop this assumption. Usually we can't assume that we know the true population standard deviation. Think about it also. You'd have to know everyone in that population. And we just said we can't do that. That's why we can't get the population mean. We can't survey everyone. So now we have to drop this assumption. All we can know is what we got from our sample. So how are we going to get around this problem? Well, is there something from the sample that we could compute and use to estimate the population standard deviation? Okay. Well, think about it. So we want to ask the question, can we estimate this parameter? Can we estimate the population standard deviation from the sample? What do you think? Is it possible?
Probably. If you're saying this,
Well, think about it for a second. We estimated mu with x bar, right? So we estimated the population mean by the sample mean. So what do you think we'd estimate the population standard deviation by? By the sample standard deviation. Make sense? Okay? So now we're going to use this as an estimate for sigma. Okay, we're going to say we don't know what sigma is, but I can get an estimate from my sample.
so sometimes you're going to give it to other times you're not.
That's right. That's right.
So you could use the standard deviation in whatever sample we got. So let's say we have the standard deviation of a sample of 100. Then we would take the, I'm trying to think of it algebraically, take the formula, right, of the standard deviation over the square root of the sample, and then we turn it, we use algebra basically to find the standard deviation that way.
Well, we would actually use Excel. Excel will tell you when you take your sample, it'll actually have a command for standard deviation. It'll let you take the standard deviation of that sample. But there's a complication, and that when we use a sample standard deviation, there's a price to be paid for that. We have to modify the central limit theorem. Here's the problem. Central limit theorem says a distribution of x bar is normal. When we know the population standard deviation, that's the fine print in the central limit theorem. Okay? And we never worried about that. We just assumed we knew it. But this is a precondition to being able to use the central limit theorem. So what happens is, when we use the sample standard deviation, that's we just use S here. When we use S in place of sigma, what happens is the error in this estimate no longer makes the distribution normal. It makes the distribution wider. Because there's uncertainty in this. This is not exactly sigma. It's off from sigma. So there's variation. And as a consequence, it makes the distribution wider. It's not normal anymore. Literally, it's not normal in either sense, okay? So this is the problem. We can't use the normal distribution anymore. Okay? We have to use a new distribution called the t-distribution. So now we have to learn how to use a new distribution. Okay? Now, the t-distribution depends on a single quantity, which is the sample size. The reason why it depends on the sample size is, as the sample size increases, S becomes a better estimator for sigma, right? Just like the sample mean becomes a better estimator for the population mean, as the sample size gets larger, the sample standard deviation becomes a better estimate for the population standard deviation. There's less variation. The curve begins to look more like normal. But this is going to depend on the sample size. Okay? And so the t-distribution uses one parameter, which is what we call the degrees of freedom. It's equal to the sample size minus 1. We're going to use this a lot. Okay? So we don't need the mean and the standard deviation with the t-distribution. Okay? Now what's really important to understand, this is a tricky point, is that this distribution is actually approximating a special type of normal distribution. It's approximating what's called a standard normal distribution. So the t-distribution, so you might want to write this down. So the t-distribution is approximating a normal distribution, but it's a special type of normal distribution. It's a normal distribution that has a mean of 0 and a standard deviation of 1. Okay? And that's called a standard normal. This normal distribution is a special normal distribution. When it has a mean of 0 and a standard deviation of 1, this is called the standard. Let me write it down. Standard normal. It's a special normal distribution.
So you're saying a t-distribution is about that?
It's an approximation to this normal distribution. Okay. Now this normal distribution is actually the z-score that we got before. Remember when we said something was one standard deviation away, it had a z-score of 1. So this is actually the distribution for the z-scores. Let me illustrate. Allow me to illustrate. Let's go back to a problem we had a while back. Remember we had that Muncie and New York City salary, right? So, and don't worry about the details, right? We had this salary for New York City, right? The mean was 60. Our standard deviation was 10, okay? And we had one for Muncie also, right? And we wanted to compare them. So what did we do? We computed the z-score for them, right? I said, okay, 75 minus 60 divided by 10. This has a z-score of 1.5. And when I did the z-score for that, I got 2.8. And the whole point was I could put them on the same normal distribution, right? This is a normal distribution that has a mean of 0 and a standard deviation of 1. And that's why it's called standard. Because every normal distribution can be put in the same distribution. Okay? So it's the use of the word standard, like when you hear someone say, Michael Jordan is a standard by which everyone else is compared to. It means everyone else is compared to him. So every distribution can be put in this form. And this is the z-score.
Unless it's an outlier.
No, every normal distribution, even if the point's way out here, it still has a z-score. And the distribution, I'm not talking about a single value. I'm talking about the whole distribution, okay? So when I compute this z-score, it's this point on this distribution. This z-score is this point on this distribution. And they're in the same distribution right now. That's what allowed me to compare those two things. Even though they're different salaries, right? Now I can compare them. Okay. So that's what the standard normal.
Problem on the homework with the ACT and the SAT scores.
It's exactly the same thing, right? So this is the beauty of the standard distribution. Okay, how do we use this? Well, what is the z-score? The z-score is how many standard deviations I am away. And isn't that what I need to get the margin of error? And the last problem, the 95% confidence interval, what was it? 2. It was 2. It was the z-score of 2 times the standard deviation. So that's how I'm getting the margin of error. It's the z-score times the standard deviation. Let's kind of flesh this out, okay? So, let me just first of all show you this is an approximation. This is not something you have to worry about. But this is the standard normal, okay? This is what the t-distribution, so what is a t-distribution? We've never seen it, never talked about it before. when you have 6 data points, the degrees of freedom is n minus 1 or 5, 6 minus 1. So this is what the t-distribution looks like. Notice it's a lot wider than a normal distribution. Okay? So this will be the t-distribution if we had a sample of size 6. Okay? If I have a sample of 14, the degrees of freedom is 1 less than the sample size. Notice as the degrees of freedom, or the sample size goes up, right, it gets thinner. It gets closer and closer to the actual standard normal. Okay? So the t-distributions, they're bell-shaped. You know, they're symmetric, but they're fatter than the normal distribution. They're wider. Okay? That's the idea. And as the sample size gets larger, they begin to approach the standard normal.
At what point does it become standard?
That's a good question. So, actually, you know, this is a project that somebody could do. If you're really interested in that, you can look at that. There's some very important implications. The answer is that there is no answer. It depends on the application. So if you're interested, you could look at different applications. And it's a very, very interesting project, actually. Okay, so T approaches, a T-distribution approaches a standard normal as n increases. Okay, so how do we do these computations, okay? So here's what we said before. We said confidence intervals x bar minus the margin of error. And now we're going to write the margin of error a different way. We're going to say it's the number of standard deviations times the standard deviation. Remember, the margin of error is a length. And remember we've been saying since the very beginning, we talked about normal distributions. We said lengths are measured in units of standard deviation, right? I've been saying that over and over and over again. That's what the z-score is. It's how many standard deviations wide the margin of error is. Now, this is a really important formula. We've been saying it over and over again, but now we're actually doing it in a very concrete form. This actually means something now. Okay, so when we were able to do this before, okay, we said, okay, 95% confidence interval for the mean. Before we knew the standard deviation of x bar, right, we said it was just 1.96. If you do it, the real math, it's 1.96 and not 2. Okay, so 1.96 is a 97.5th percentile for the standard normal. You should convince yourself you believe that. If that's not obvious to you, sit down in Excel and see if you can convince yourself that. That's an important fact. Okay, so what this means is, this means that if I look at the standard normal, and I look at the 97.5th percentile, the z-score is 1.96. And if I multiply it by the standard deviation, I get the margin of error. That's when I knew sigma. Okay? So I'm going to have to do something different now. Okay? And so this was the picture we had for you. It's two standard deviations, 1.96, right? Okay. So here's how we're going to use a t-distribution now. It's going to be a little bit different. Compare and contrast, okay? When we know sigma, okay, in other words, I know standard deviation for all the x, the margin of error is this. It's the z-score for the 97.5th percentile, okay, times the standard deviation of x bar. So this is roughly 2. Okay? Times the standard deviation of x bar. Does anyone not understand that? If you don't, now's a good time. So here's what we're doing. Let me just draw you a picture. What I'm going to do.
So you're just applying the x bar. It's the exact same thing we've been doing, it's just you're putting a different name to it.
I'm sorry, what's that?
So you're just calling it the z-score even though it's the exact same thing we've been doing. It's just called the z-score now.
Right. It's telling me how many standard deviations I have to go out. So this was 2 before. If I look at the standard normal, the standard normal tells me how many standard deviations to go out. And then this, I'm just going to multiply it by the standard deviation. Okay, so this says you go out this many standard deviations, then I multiply by the standard deviation. That's the margin of error. Here's what it actually looks like if you draw the picture. You might want to draw this picture. So here's the true mean, if we draw the 95% confidence interval, okay, this is, and I'm going to draw the standard normal down here, okay? This is the z-score. Okay, I know that the 97.5th percentile for the z-score is around 2 for the standard normal. Okay, so z of 0.975, that would be norm.inv of 0.97501. Okay, that's roughly about 2. And this thing up here for the 95th, for the 95th percent confidence interval, the 97.5th percentile here is the z-score times the standard deviation. Okay. The empirical rule tells me this. It tells me when I go out 2 standard deviations, this is how I'm getting the 2. Okay. This is my z-score. So I'm getting the number of standard deviations from the standard normal, and then I'm multiplying that by the standard deviation to get the 97.5th percentile for x, or in this case, x bar. Okay. So when we did that, okay, we go through the math. Okay, we use the standard normal. We get the 97.5th percentile for the standard normal and multiply by the standard deviation of x bar. Okay. So even if the theory is a blur, the methodology is easy. I go to the standard normal like we just did a second ago, right? We go ahead, we find a 97.5th percentile, multiply by the standard deviation of x bar. Okay, what do we do when we don't know the standard deviation and just the sample standard deviation? Notice what we do. We swap t for z, and we swap sigma for s. And that's all we do. And the formula is exactly the same. So now I'm going to get the 97.5th percentile in the t distribution instead of the standard normal. And I'm not going to multiply it by the population standard deviation. I'm going to multiply it by s. Exactly. That's all I know. That's my estimate. Okay. So it looks like this. So I go to Excel and I use t.inv. I say, tell me the 97.5th percentile for this distribution, and then I'm going to multiply it by the standard deviation, the estimate for the standard deviation of x bar. This is now an estimate for the standard deviation of x bar, right there. Okay. So the big thing that we have to know is how to compute a certain percentile for the t distribution. So here's what we're going to do. We're going to calculate the degrees of freedom. It's always the sample size minus 1, so that's easy to get. And then I'm going to go ahead, I'm going to do the same thing. I'm going to calculate my percentile the same way. Nothing's changed. This is easy to get. This is the same as before, right? Okay. And I'm going to use Excel. A new command, though. For some reason, it doesn't want to bring up all of these things, so I'll just do it like this. So here's the Excel command. It's like norm.inv, except it's t.inv. I put in my percentile, I put in my degrees of freedom, and it gives me an approximate z-score. Okay? It gives me a t-score, which is like an approximate z-score. Let's do an example. Let's see how this works. Okay, so let's go ahead and let's calculate let's calculate the t-score for a 95% confidence interval given a sample size of 30. So let's think about this for a second. So what do we know? What do we need? Let's go ahead and look at this. We need a couple of things, right? We need x bar. So for any confidence interval, I need x bar and I need the margin of error. X bar I'm going to get from my sample. We're going to take a sample in a second, okay? The margin of error is going to be the t-score times S divided by the square root of n. Okay, I'm not going to have a z-score. I'm going to swap that out for the t, but I'm not going to have sigma. I'm going to have S divided by the square root of n. So I need a couple more things, right? I need these three things. Okay, I need the t-score, S, the square root of n. So let's just practice at getting this, okay? How do I get the t-score? I want the 95% confidence interval. Okay? So let's look at how to get this t-score. This is going to be the t-score of 0.975 with n is 30, 29 degrees of freedom. So the t-distribution has two parameters that have to go in. I have to tell it the percentile, because if you think about it, for the 95% confidence interval, right? There's 95% in here. There's 2.5% here. So I want the 95% confidence interval. I mean 97.5 percentile. Sorry. Okay. And I have a degrees of freedom of 29. Because the degrees of freedom is always n minus 1. Now I can get that value. Okay? So the first thing I need is the percentile. That's going to be the 0.975. Notice that didn't change, right? That's the same as before. I don't know if it will let me write it on here. This is acting bizarre. Let's see. Here we go. Okay. And now I need the t-score. I have 29 degrees of freedom. And I'm going to do this in Excel, otherwise I'm not going to be able to get an answer in PowerPoint. So let me do this. Okay, so I'm going to say n is equal to 30. We'll just set up a little chart here. Degrees of freedom, which is equal to n minus 1. That's going to be equal to 30 minus 1. Okay. My confidence is 0.95. So my percentile is going to be 0.975, right? I won't use the formula here, right? But everyone's convinced that's true. So now I'm ready. For t.inv, I need the percentile, I need the degrees of freedom. These are the two things I need. Okay? Now I'm ready to go. So I'm going to type, I'm going to get the t-score here. Whoops. So we'll do this slowly. So this is going to be equal to t. As soon as you type t, it gives you all these possibilities, right? I'm going to go down to t.inv right here. Click on that. Probability is just percentile again, right? So I'm going to put 0.975. I'm going to use my degrees of freedom here, 29. And that's it. Excel says just go put a parentheses. And that's my t-score. Notice it's not the same as the z-score. The z-score is 1.96, right? We said the t-distribution is a little bit wider. So this t-score is not 1.96 like the normal. It's a little bit bigger. It's 2.04. Okay? So now all I have to do is multiply that by s times the square root of n. I'd have the margin of error. Okay? But the main thing is we have to get the t-score. That's the hard part. The s is easy. The n is easy. The s we get from the sample. The n we know, okay? That's the hard part. Okay, questions on that? I know this is a lot, okay? T-distribution is a new concept. Okay, let's go ahead and try another one. Let's see. Suppose we want the t-score for 95% confidence interval, but now the sample size is 100. Okay, the confidence interval is the same. It's just the sample size is changing.
So we just change,
For one of these, you go ahead.
just change the degrees of freedom to 99.
Exactly. Well, right. In fact, if I change this to 100, everything will automatically change. Watch. Okay?
And then,
What happened to the t-score? It shrunk. Why? Because as the degrees of freedom are going up, the t-distribution gets more narrow, right? So this guy gets more narrow. Okay? Yeah?
Can you just compute the margin of error once? Like I did it, I just want to make sure I did it.
I'm sorry, which, you want to click on this one here?
Will you just compute the margin of error, like for this?
I'm sorry, I'm still not following. I'm sorry.
The margin of error, can you compute it?
Oh yeah, well, yeah, so do you want to just, you want to make up a standard deviation? Go ahead and give me a standard deviation.
Well, I didn't know if we were supposed to do this on these, or if we just completely skip that.
Well, we are going to. Right now we're getting the t-score. Because this is going to be easy. This we're just going to compute from the sample.
Okay.
Do you,
So S
should we?
is the sample size, right?
The S is no. S is the sample standard deviation. Let's go ahead and go through and go through a full example.
What's the 99th percentile?
I'm sorry.
What's the 99th percentile?
That's a good question, and we're gonna do that next. That's the next one. You read my mind. Okay, I'll tell you. Go back to the one that you had for the sample size of 16. Do you still have that calculation? Go back to that problem.
Yeah.
You got it? Everyone has it? Okay. So now let's compute S for that. Okay, so we're going to type SD dev. Notice it gives you a lot of options, right? I want the sample standard deviation, that's the S. P is for population, okay? But I only have a sample, I only have 16, right? So I'm going to go ahead, I'm going to click this, okay? And now I'm just going to choose the values in my sample, right? So this was my sample. Just go to the first value in your sample and say Control-Shift down arrow. And that's going to give you your S, okay? Now, that's not the standard deviation you want to end up with. That's the estimate for sigma, right? What did we have to do with sigma? You guys know from the homework, right? What did we have to do to sigma to make it work for x bar?
Divided by the square root of n.
So I have to divide the estimate by the square root of n. So this is actually S of x. Okay? I want S of x bar, which is going to be equal to S of x divided by the square root of n. Okay? So now this is going to be equal to whatever this is, and it's going to be different. You're not going to get the same numbers, right? We had different samples, right? We're going to have different standard deviations there, but we're going to take whatever that number is and just divide it by the square root of 16, which is 4. Okay. So what we have now is we have this part, right?
Yeah.
Now we're going to multiply it by the t. And everyone's going to have the same t, right? So go back and pick off that t that you just had a second ago. We'll just say 1.984, okay?
Get the 16.
I'm sorry?
Where did you get the 16?
Remember, we chose a sample size of 16. That was just the sample size that we chose for that problem.
So we're not using 29.
Oh, you know what? I have to change this. I got to change this. Thanks. Yeah, thank you. If I'm going to make this work, I have to have the same sample size. Thanks. Okay, that's going to change the t-score. It's a really good point. Thanks. Yeah, because I have to choose this t-score is based not only on the confidence interval, but it's based on the sample size. Thank you. Okay, so now I'm going to use 2.13. Okay. So now I'm going to say that my t-score is 2.13. I could compute it over, but that's okay. And now the margin of error is equal to t-score times the standard deviation of x bar.
What's your t-score?
It was like 2.13. Okay. We can compute it. Let's compute it over again. It's I want to do norm. T.inv. Okay. It's going to be 0.975, and I have 15 degrees of freedom. Okay, because I have 16 points, right?
Okay.
Okay, so now it's just going to be standard deviation of x bar, and that's going to give us our margin of error. So it's going to be this times, whoops, times that.
Can I see your formula for S of X?
It's just this, divided by 4, square root of 16. Yep. Okay. And so your margin of error should be that. Okay. Now you can compute the 95% confidence interval. I'm going to take x bar plus or minus this margin of error. This is almost always the honest way of doing it. Okay. You almost never know that. I'm sorry. You know why? I apologize. Will this number be the same for everyone?
Oh, so
No, it will not be. It will not, because I'm not using sigma. We're not all on the same page. We're all using a different sample standard deviation. Thanks. Yeah. You should get something close. Your value should be something close to this, right? But we'll all be different. Different samples, different
Close to
samples.
what?
Should be something close to this.
So for that, I have 2.04 for.
Yeah, that sounds about right. In that. Yeah. Okay.
And it's 2.17. So is that further off?
That's in the realm of possibilities. That isn't bad. Yeah.
Mine's 2.6, is that too much?
That's a little high. I should take a look at that just to make sure. That sounds a little high.
I got 1.15.
How many? What's your sample size? Do you have 16 in your sample size? Okay, I'll take a look. That looks a little high. Okay. So these are the steps that we're going through. Now I'm going to take x bar plus or minus. This is almost always the honest way of doing it. We rarely know the population standard deviation, and what's going to happen is because the t-distribution is wider, it's going to make our confidence interval wider. So it's going to say, well, it's a little bit wider. It's kind of conservative. Okay. We're going to tend to use the t-distribution and not the standard normal, because it's rare that you know the actual population standard deviation. Okay, questions on that? Okay, let's see. Okay, so let's do one more for fun. Okay, 99% confidence interval. We'll use the same value, so it'll be easy. Okay, it'll be easy. 99% confidence interval. Okay, everything will be the same except this little thing on the t-score. Everything else is the same. I have the same x bar. I have the same sample. I have the same sample standard deviation. I have the same n, right? The only thing that's different is the t.
0.01.
Let's puzzle through it. Let's puzzle through it. This is a little tricky. So I want the 99% confidence interval, right? Okay, so let's draw a picture, right? Pictures are great. So I want 99% here. So we can subtract 100% from 99%, right?
Yeah.
1%? Right, so the tail has 0.5%, which is actually, if I move this over 2 more decimal places, 0.005.
That'll be 0.995.
That's it exactly. See how easy it is? Piece of cake.
It's like pie.
I wouldn't count
It's like cupcake.
It's like pie, it's like cake, it's like a muffin, it's easy, right? No problem. Okay, so this is 995, right?
Sure.
What should happen to that value? Should that value be bigger?
It should be smaller.
Should be smaller or bigger?
Smaller.
We're going out further, right?
It's going to be bigger.
We have less in the tail, so it has to get bigger. Okay? That value should be bigger. And sure enough, you should see that your confidence interval gets larger. Okay? All right. It's 8:45. We got 5 more minutes. Anyone have any questions? We have time. Everyone's good? Everyone's done?
This
Stick a
pie is
fork in you? Yeah.
Look at this.
I want to take a look and see. Yeah, make sure. It can happen. It could happen. Let's see. Could we put that? Yep. Yeah. It's gonna fine. You just got a really weird sample. Yep, that's right. Everything's right. 16, 15.
And it's 9,975 dollars.
Yes, that's correct.
So that's just a weird buddy.
You did everything right. So you just got a weird. So you can get that's a really big variation in standard deviation. 2.4 to 2.8. That's 1/3 of the standard deviation. That's a lot. Okay, so
Is our, oh, go ahead.
I have to give you the midterm. I would feel terrible if you left without it. It's open book, open note, open whatever. It covers everything that you've done. Like I say, if you want to have more time on the quiz, feel free to turn in later. I probably won't put time in on that. I'm more concerned that you do it and take the time to think about it.
Oh my gosh.
You haven't even seen it yet. Jeez.
I can feel how thick it is.
They could all be easy problems. Like, what's your favorite color, right? What's your favorite?
What is the probability that your favorite color will be this, depending on this, depending on this?
2 trains
No.
full of them.
No, it's not how
And if you want to talk about projects, definitely contact me. I can talk about it. We'll puzzle through it.
Is our homework on the grade book weighted, how it's supposed to be weighted in our...
It's going to have to be weighted a little bit later. I'm not sure. I'll have to talk to Janet. We haven't figured out the weighting. But I will get everyone's homework.
So it's not, our current grade is not really our current grade, technically.
I sure hope not, because
We're going to be conservative in the weighting, but I don't think she's actually worked out the exact rubric. So
And we'll still get the attendance points at the end, right?
absolutely. At least what she promised you, minimum. All right. Let's see. I want to save this.
By the way, thank you for working that homework out with me.
Okay, sure. Yeah, it's just little tricks like that.
Yeah.